These two triangles are similar. How do I know? Well, they're both right, and they both share a 32-degree angle. That means the third angle in both triangles is 90 minus 32, or 58 degrees. So they share all three angles. That makes them similar. Now, similar triangles also have common ratios of sides. So for example, if we label these sides A and B, and the sides over here C and D, the ratios of corresponding sides, so A and C, to B and D are the same. So A divided by B is equal to C divided by D. And that's true for any triangle that has a 32-degree angle. Since all right triangles that share an angle theta have the same ratios of sides, it's useful to give those ratios names. Let's start by giving the sides of the triangle names. The longest side, opposite the right angle, is of course called the hypotenuse. The side that's opposite the angle theta we'll call the opposite side. And the side that's next to the angle theta, but not the hypotenuse, we'll call that one the adjacent side. That's a fancy word for next to. So we'll define three ratios. The first one we'll call the sine of theta. And that's written like this. It's equal to the opposite side divided by the hypotenuse, the lengths of those sides. The second one is called the cosine of theta. It's equal to the length of the adjacent side divided by the hypotenuse. And finally, the tangent of theta is equal to the ratio of the opposite side to the adjacent side. You can of course also take the reciprocals of these, and those also have names, but these are really the three important ones. A good way to remember these ratios is the nonsense word SOHCAHTOA. It stands for sine equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. As an example of how we can use these ratios, let's suppose that this triangle has a hypotenuse that has length 8.3, and we'd like to know the length of this side, x. Well, we note that the trigonometric ratio sine of 32 degrees is equal to x, the opposite side, divided by the hypotenuse 8.3. Now we can easily solve for x. We simply multiply both sides by 8.3 and we end up with x equal to 8.3 times the sine of 32 degrees. So how do we evaluate this? Well, we need to get our calculator out. And the first thing you want to do is to make sure that your calculator is set to use degrees. There's another way to measure angles, which is called radians, which you'll use later. But right now we want degrees. So to do that, if you're using a TI calculator, you press the mode button and use the arrow keys to go down to the third line and change radians here to degrees. It might already be set up for degrees, but it's best you check, otherwise you'll get the wrong result. And then we press second quit to go back to the main screen. So let's evaluate this. 8.3 times the sine, and the sine button is right here above the comma, of 32. And you can close the parentheses if you like, and press enter. And we end up with this result, 4.3983, and so on. And we'll probably only keep the first two decimal points in this side. So we find that x is equal to 4.4. So let's look at another example. In this triangle we have a 51-degree angle, and we know that one of the sides has length 11, and we'd like to know the length of the hypotenuse. So we note that we can form the trigonometric ratio, the cosine of 51 degrees, by taking the adjacent side divided by the hypotenuse. So cosine of 51 degrees is equal to 11 divided by h. And once again, we just solve for h. So we can do that by multiplying both sides by h and dividing both sides by the cosine of 51 degrees to get h is equal to 11 divided by the cosine of 51 degrees. Then we get our calculator out again and simply enter the, oh, my calculator's frozen. Let me restart it here. Simply enter this expression into our calculator. We've got 11 divided by the cosine of 51. And we get 17.479. Maybe we'll round that off to 17.5. One last example. This time we have a triangle with an angle of 75 degrees. And we know that one of the sides is 9.2. And we'd like to find the side B. So let's write the trigonometric ratio between these two. And relative to angle 75 degrees, that's going to be the tangent. So the tangent of 75 degrees is going to be equal to the opposite side, that's 9.2, divided by the adjacent side, which is B. Now, once again, we solve for B. So B is equal to 9.2 divided by the tangent of 75 degrees. Then we need our calculator, so we get our calculator out and we evaluate 9.2 divided by the tangent of 75 degrees. And we press enter and we get 2.46. Round that off to about 2.5. So B is equal to 2.5.